Hello everyone, I am Dr. Banal Sarita. Today I am going to deliver Unit 3 of Machine Learning Algorithms, focusing on supervised learning techniques and their applications. In this unit, we will study supervised learning and unsupervised learning, the two major categories of the supervised learning algorithms like regression and classification. We will also explore various algorithms used for prediction and decision making tasks. Supervised learning is one of the most widely used machine learning paradigms. It learns from labeled data, training data, where both input and corresponding output are available. The objective is to learn a mapping function that can accurately predict outputs for unseen data. In supervised learning, labeled input data is provided to the model during training, and the model learns the patterns and relationships between the inputs and outputs. Once trained, it can predict outcomes for new data. Common applications includes house price prediction, email classification, and disease diagnosis, also customer behavior analysis. And supervised learning problems are broadly classified into two categories. One is regression problem and classification problem. So we can see in the slide regression as well as the classification curves. Regression predicts continuous numeric values such as house price, temperature or stock prices, whereas classification predicts discrete values or categorical values or labels such as spam or not spam, or disease detection like yes or no, image recognition. The choice of the algorithms depends on the nature of the output variable. Linear regression is the simplest regression technique. It models the relationship between input and output by using a simple straight line equation where the equation is y equal to mx plus c, where m represents the slope of the line and c represents the intercept. A linear regression is widely used for trend analysis, forecasting, and prediction. Problems where a linear relationship exists between the variables. When data does not follow a linear regression or linear patterns, the advanced regression techniques are used. Like polynomial regression, it captures the nonlinear relationship between the models by fitting the curved models. Ridge regression reduces the overfitting by adding a penalty term to the loss function. Also, Bayesian linear regression introduces the probability and uncertainty estimation into the prediction. So these are the various regression models, and these methods improves model flexibility and prediction accuracy. And regression trees divided data into smaller decision regions and make predictions based on the hierarchical decisions. Nonlinear regression is used when the relationship between the variables is highly complex and cannot be represented by a straight line. These techniques are useful for solving real-world problems involving complicated data patterns. Despite its name, logistic regression is a classification algorithm. Even though it is mentioned as regression, it will be considered as a classification algorithm. It uses a sigmoid function to convert the numerical values into probabilities that ranging from 0 to 1. Based on the threshold value, the output is assigned to the particular class. Like if threshold is greater than 0.5, if threshold value is 0.5, if your input is greater than 0.5, then we can treat this as the 1 output. If input is 0, then it is below the threshold voltage, so it is considered as the 0. So based on the threshold voltage, the output is assigned to the particular class. Applications of logistic regression are disease prediction, spam detection, customer churn prediction, and sentimental analysis. Decision trees classify data using a sequence of decision rules and conditions. These are simple to understand and interpret. So some of the decision trees are KNNs, K nearest neighbors, or KNN, or classifies the data point based on the majority class among its nearest neighbors. Both methods are widely used due to their simplicity and effectiveness in classification tasks. And coming to support vector machine, or it is usually pronounced as SVM, finds the optimal boundary called hyperplane that separates different classes with maximum margin. And Navi-Bayes is a probabilistic classifier based on the Bayes theorem and assumes independence among the features. These algorithms are commonly applied in text classification, image recognition, and medical diagnostic system. Let us summarize the unit. So we have discussed supervised learning algorithms and unsupervised learning algorithms. So supervised learning algorithms like regression algorithms such as linear regression, polynomial regression, ridge regression and regression trees predicts the continuous values. And classification algorithms such as logistic regression, decision trees, KNN, SVM, support vector machine and Navi-Bayes predicts the categorical outputs. The key to success machine learning is selecting the appropriate algorithm based on the problem type and nature of the output. Thank you for watching this video. In this session, we learned the fundamentals of supervised learning, explored regression types and classification techniques, and also discussed popular machine learning algorithms used. Thank you.